continuing our exploration of multiple choice found on the final exam study guide, section 8 of Moodle. Section 8 has the study guide. Sec 8 Moodle, written in highlighter. Which of the following is or are chiral? Well, there is no definition of chiral that has the word stereocenter in it for a reason. There are chiral molecules that don't have any stereocenters. There are. You got to believe me. But if you have a molecule that has one stereocenter, it will always be chiral. Okay? That's not a definition of chiral, but I'll tell you, if a molecule has a single stereocenter, no other stereocenters, it's going to be chiral. So I'm going to use that to rule out number 3, because there's not a single stereocenter in number 3. This is not a stereocenter here. It's got 2 H's on it. So that's a no. I hope you see that number 2 is this. This is 2. I'm just going to look at it sideways. Here's the bond from the front to the back. Here's the back. I'm just copying what I see on the back. Is that not a CH3? So is this a stereocenter? So it's a simple molecule without any stereocenters. That's a good approximation for the definition. And no, not chiral. So that's getting a big X on that one too, which means this one. And 1 looks good. I'm just going to rewrite 1 here. This is 1, BR, H, CH3. Here's the bond going to the back carbon. Here's the back carbon. CH3, CH3, H, this is number 1. And that is the stereocenter, right? Here are your groups. You ready for the names of the 4 groups? Hydrogen is 1 group. Bromine's another group. Methyl's another group. Isopropyl is another group. 4 different groups. That's a winner, winner. Here's the answer. Uh-oh. It has a bit of a, just want to make sure A is the answer, okay? 2 and 3, no go. How many isomers, constitutional and stereo, for dimethylcyclopentane? Well, how many ways can you put 2 methyls on here? Can you not put them both on the same carbon? Is that not enough? We're not allowed to put 2 methyls on the same carbon. That's what I got as an answer from one of my best students. So no, I think she's going to rethink her answer. Okay. This is definitely possible, right? I mean, that's a molecule that fits the word, okay? And there's no sister trans on that. You're not saying sister trans. One of those methyls is up and one's down. Yeah, the other trans. No, you don't do that. But when you get to 1, 2, there's 3 isomers possible. What? There's 2 stereocenters. Why are there not 4 isomers? That's a great question. There are 4 possible ways to do it. RS, SR, RS, RS, SR, those what might be enantiomers, and SS and RR, they might be enantiomers. But I'll tell you, RS are not enantiomers because they look like this. That molecule does not have an enantiomer. Why not? It's meso. You want to see its mesoplane? Here it is. Mesoplane right through this carbon in the middle of those 2. Yeah. These H's see each other across the plane. The methyls see each other across the plane. These carbons see each other across the plane. So do these carbons see each other across the plane. And this carbon got cut in half in the middle of the plane. No enantiomer. But this one has an enantiomer. And here is the enantiomer. right? Now, what about 1, 3? So these are the two 1, 2s. This is 1, 1. This is 1, 2. This is 1, 2. Okay. And then there is 1, 2 meso. It's a molecule, but don't draw 2 of them there. What about 1, 3? 3 extra molecules is what you wanted to say? She may have said 4 by mistake, but we have the same issue. This one does not have an enantiomer. Does it? Also meso. You want to see the mesoplane? Here it comes. Right through the middle of that and through the middle of those two. Yeah. But this one has an enantiomer, and this is the uh-oh, don't be crashing on me now. A little touchy right now. Already had a crash today. Counting my molecules now. 1, 2, 3, 4, 5, 6, 7. We good? Yeah, that was a little deceptive, that one, wasn't it? A good video then.